Imagine you are a founder of an AI company and you build AI support agents. And tonight on your screen, there is an RFP, a request for a proposal. It's a form with a bunch of questions that you have to answer in order to sell your software product to large enterprise clients. And this one is worth millions of dollars. If you win it, it can change the course of your company. And you're moving through it just fine. Until question 14. How do you verify the accuracy of responses by your AI agents? And you feel stuck. Because the honest answer is, you don't know. Now here's the thing, every company filling out this form tonight falls into one of the two groups. One group will write whatever sounds right, because they have to write something. The other group is about to write an answer which they have spent many months to earn. And by the end of this video, you will see exactly how to answer that question. Let's go back 6 months from now. Two companies, call them company A and company B. Both of them build the same thing, an AI support agent that e-commerce brands can put on their online stores to talk to their shoppers. Both the companies landed their first real enterprise client. Not exactly $1 million deal from tonight, but still important. Two separate clients, similar size, same industry, online retail. The kind of store that gets around 10,000 support conversations every month. This video is about what happened in those 6 months. Now, look at the position that founders are in. There are three players here. The founders who build the AI agent, the enterprise client, that is the online retailer, and the shopper, the end customer, who is just trying to get some help. The shopper believes that they are talking to the online store, and the store is trusting the founders to get all the answers correctly. So every answer that this AI agent is writing, it is writing on the behalf of someone else, on the behalf of the enterprise client to the shopper. And see, this loop is not new. For 30 years, chat's office sat in the exact same place, between the store and the shopper. But these softwares had exactly one job: move the message from shopper to store and vice versa. The shopper would ask a question, a human support agent sitting on the client side would read it and reply it themselves. The intelligence in that loop was always a person. Now, the software writes the answer itself. Both agents go live, and for the first few weeks, it feels like magic. It seems like the AI support agent can handle pretty much any question that the shopper threw at it. But then, around the same time, both the founders got the same email forwarded from their client. A shopper had written back to their support team, "Hey, where is that refund that you promised me?" And after looking into it, it turns out that the AI support agent did promise her a refund. Except she was not eligible. And here's the scary part. Nobody wrote code which says promise refunds, especially to shoppers who are not eligible. There is no line to point at. There is no bug to fix. So the founders did the only thing that they can. They pull out a sample of a month's conversation, a few hundred, because nobody can read 10,000 conversations. And they found out that roughly 1 in 10 conversation had something wrong in it. Wrong answers, made up policies, promises nobody authorized. And with this evidence of 10% wrong answers, the founders remembered that email thread by their client, where they have asked one more question, the most gut-wrenching question. How do we know this isn't happening in other 9,000 plus conversations? Okay, so why does that question has no answer? Actually, for 50 years, it did had an answer. A boring one. The test shows green. Software used to be a bunch of rules written in code. Rules stacked on top of other rules. Every single behavior can be traced back to a line of code that somebody wrote. And we just wrote tests to check those rules. And when the test suite shows green, it meant that the software worked. In principle, 100%. That's why you trust a bank transfer. You send money, the same amount leaves your account, and the exact amount shows up on the other side. But an LLM-based AI agent is not based on rules. It's probabilistic in nature. It doesn't follow instructions. It predicts. And if you're thinking that this is some kind of flaw that they will fix in the future, you're completely wrong. The probabilistic nature of AI agents is a feature, not a bug. Because these AI agents can speak human language, like English. And human language is ambiguous. There are no predefined set of rules that can pin it down. So anything that speaks it has to work in probabilities, which means that your test suites, your unit tests, your integration tests, and your end-to-end tests won't work. Those tests will only check the part of the product that work on rules. But what about the part that talks to your client's customers? A test suite that shows green for that part doesn't exist, at least not yet. So, two companies, same week, same disaster. Company A treats it like a bug. They tweak the system prompt saying something like, "Never promise refunds to shoppers," and they redeployed it. Tried a dozen conversations, seems fine now. They replied to the client, "The issue is resolved," and move on. Notice those two words, by the way, seems fine. Company B does something much less satisfying. Before they replied to anyone, they asked a very simple question. If we fix this issue, how would we even know? So they sat down and they read hundreds of conversations from that sample, labeling every single one of them, the good, the bad, and the reason for it. Painfully manual, painfully slow. But it's the first real answer to the client's question. We know because we looked at it. A month later, the difference starts to show. Company A's fixed worked, by the way. The agent stopped promising refunds. But it also started refusing refunds to shoppers who are actually entitled to it. Hundreds of conversations that used to go fine earlier are now going wrong. And nobody knows. Because nobody's looking. And every prompt tweaks works like this. You squeeze one problem down and another one pops up somewhere else. It's like playing a whack-a-mole. Until eventually, Company A's teams get scared of their own product and they just stop touching it. Company B has the opposite problem. Looking actually works, but you cannot read 10,000 conversations every month. That kind of defeats the whole point of using AI. So they automated the looking. They built a system that automatically reviews every single conversation and scores it. The same way a support manager would review the work of a support rep. First run across all 10,000 conversations, 9,000 were good and 1,000 bad. And the bad ones were sorted into named buckets. This system has a name. It's called Evals. And now the answer to the question, how do you verify the accuracy of your AI generated responses, is simply we measure it. But hold on. How do you score 10,000 free-form conversations automatically? A rule can't do it. We already established that. There is no regex for, was this answer actually helpful? So company B did something that should bother you a little. They used another LLM to judge the first one. And if you're thinking, wait, who verifies that judge? That's exactly the right question to ask. It's the same question from earlier, just one level down. So here's the escape from that infinite recursion. Remember those hundreds of conversations that company B manually labeled? That's the answer key. You take the judge and you test it against the human verdict, and you keep tuning it until it agrees with humans, say 95 times out of 100. And now you can trust it to grade the rest of the 10,000 conversations that you'll never read. This is honestly the oldest move in the machine learning domain. Now, how can you actually build a judge that you can trust? That's a whole video of its own. But this is the step that turns seems fine into a number that you can actually trust. And a number that you can actually trust changes everything. Company B ships every week now. It changes the prompt, runs the eval, and it gets 90% accuracy. Changes something else, and it gets 95% accuracy. Changes something more, and it gets 98% accuracy. Never 100%. That's gone forever. This is probabilistic software, remember? But it's a known 98%. And here's the part that really matters. The clients understand this as well. Meanwhile, company A learns about their numbers from Twitter. A shopper posts a screenshot of the AI agent inventing a new discount that doesn't exist. And it's the store's brand sitting in that meme. Months later, company A's client quietly churns. And their logo quietly comes off the company's A's homepage. Which brings us to tonight. That screen, that RFP worth millions of dollars. The biggest retailer either of these companies has ever pitched, and both of them are filling out the same form. Company A needs that deal to replace the revenue that they just lost. Company B also wants it. For them, it's growth. They are staring at the same question. Question 14. How do you verify the accuracy of responses by your AI agents? Company A writes, we configure our AI agents correctly to make sure of that. But you know that's not enough. And Company B writes 98.2 conversation accuracy across all production conversations last quarter, measured continuously by evaluators that we validate against human review. The remaining 1.8% is categorized and tracked to be improved upon. The RFP asks one follow-up question. How does your AI agent handle policy-based decisions like purchase refunds? Remember the refund, the disaster that started this whole story? The answer to that question, our AI agents issue refunds themselves now, is one of the most heavily audited features we have. Now, same model, same product, same disaster even. The moat was never the AI. Everyone has access to the same AI models now. The moat is knowing exactly how reliable your product is when nobody else can. So for 50 years, how do you know your software actually works had an easy answer. AI took that answer away. And evals is how you get it back. Software testing built the trust that 50 years of software ran on. Evals are how you build that trust now. So if you have an AI agent deployed somewhere that is talking to the end customers, I have a question for you. How do you know that it works? If you find this video helpful, don't forget to like the video, and for more videos like this, subscribe to my channel. Thanks a lot.